This is Mr. Peterson with another screencast for AP Environmental Science. In this chapter, we're going to learn about non-renewable sources of energy because we've got to make the best of what we've got because there isn't any more coming down the line anytime soon. Ultimately, almost all of these sources of energy, come from the sun. Because all of the fossil fuels that exist today came from the remains of dead plants and animals that lived millions of years ago. And they got their energy to grow from the sun. So in many ways, when we burn fossil fuels today, we're releasing long-stored solar energy. The sun is what drives almost everything, energy-wise. The exception comes at the end of the chapter with nuclear power. But for now, the sun provides the ultimate source of energy for our renewable sources of energy: solar, wind, hydropower, and biomass energy. It also supplied the energy to form most of the non-renewable sources of energy like oil, natural gas, and coal. They're just non-renewable because the time it takes to create them is much longer than we can wait. So for now, about 82% of the energy we use in the world comes from non-renewable sources, and the other 18% comes from renewable sources. That renewable percentage will have to grow over the next few decades and centuries because there is no alternative. Someday, the non-renewable resources will run out. Now, humans have had a long history with using energy. The first instance arrived with using fire to cook and heat with. Slowly, we graduated to using natural forms of energy, like wind to move from place to place, to power machinery, pump water, and we even learned to use the moving water to power even more machinery. Using wood again. Wood had always been used to heat with, but the arrival of the steam engine prompted a global deforestation that was pretty shocking. As forests were cleared to provide energy for steam engines, it quickly became apparent that the forests weren't going to last and we need to move on to something else pretty quickly. So, you can see the environmental science, while really a field that's been heavily focused on recently, has existed back as far as human history goes. But by the 1850s, the focus for energy shifted to coal. Coal had been known about for a long time at this point, but by the 1850s the technology existed to mine it efficiently, and it was readily available substitute for burning wood. You can burn it for heat in a fireplace like wood, and you can burn it to generate steam to run a steam engine. It's still used to make heat to boil water, to make steam to turn a turbine in a coal-fired electricity power plant, and a side note, it is the #1 electricity producer in the United States still. We'll get to those specific facts later. The next energy source we learned about was oil, and as technology developed, we learned to locate it underground and pump it to the surface, and we discovered ways to convert it into things like gasoline and heating oil, and car engines, and all kinds of other stuff. We've developed all kinds of things that run on gas, and the rest is history. The last major source of non-renewable energy comes from nuclear power. We have learned to exploit nuclear power, where we split uranium atoms to release massive quantities of energy to generate electricity. The problem with all of these energy sources is that they have some pretty serious pollution problems, both from obtaining the fuel, processing it, and then the leftover waste after using them for energy. Let's get into the specifics of each kind of non-renewable energy. First up, oil. Oil is really a substance that comes out of the ground called petroleum. It's also called crude oil because it hasn't been refined yet into any of the numerous things that come from petroleum. Oil is a type of fossil fuel. It's named that because they're the leftover decayed remains of plants and animals that lived millions of years ago. Not all organisms from those time periods ended up making fossil fuels. They had to get covered up by soil and buried underground, and then rock formations had to change over long periods of time to make formations that could trap the oil under the domes of rock, and the oil couldn't pass through. It takes a very specific set of conditions to create oil, and that explains why some areas of the world have lots of oil, while others have none. It is extracted from the ground by drilling a well down into a layer of oil-containing rock. When the well hits the layer containing the oil, pumpers are used to bring the oil to the surface. Oil in the rocks near the well flows toward the well by gravity because the layer of oil has been lowered right around the well. Eventually, the entire layer of rock has had all of its oil removed and the well will go dry. Up above ground, the oil goes through a process of refining to turn it into useful products. You can see in the picture all of the various products that are made of oil, and they're separated by a pretty nifty piece of chemistry. The crude oil is heated and it flows into a distillation column, which is a long vertical tube. Each chamber is kept at a different temperature, and the temperature decreases as you go up the column. At each temperature level, different components of the petroleum will condense. The parts that take very high temperatures to boil condense at the lower levels, where it is hottest. Each level cools as it rises. And at certain temperatures, each of the pictured products condenses and is collected, stored, and shipped. The lightest, most volatile components, like gasoline and natural gas, are collected at the top of the tower because they condense at the lowest temperatures. All of these commercial products of oil are called petrochemicals because they're made from petroleum. Now, oil reserves are identified deposits of oil that can be extracted with current technology, while being profitable to do so. This is a global map of oil reserves by country. The abbreviation on the key stands for billions of barrels, so the darkest shading represents countries with large oil reserves, like Saudi Arabia, Iraq, Iran, Russia, Venezuela, and surprisingly, Canada. The countries that make up the Organization of Petroleum Exporting Countries, OPEC, shown in blue here, control about 60% of the world's oil reserves and produce around half of the world's oil every day. Because they control the majority of the reserves, they have a lot of control over how much oil is produced every year, which keeps it profitable for them. One of the problems with estimating oil reserves includes the secrecy of each country regarding its own oil reserves, and OPEC's secrecy. It would be a massive blow to them if their reserves were actually smaller than the public estimates, because then they wouldn't control the majority of the world's oil. But as long as we think they do, we have to play along. But it's not a question of if the oil will run out, it's a question of when does it start running out, enough to make production slow down so that prices start to rise that we need to be concerned about. Eventually, it's going to happen. Well, it's happening now. And when it does, the price of oil is going up enough to force one of several things to happen. Either we will start using renewable sources of energy like wind, solar, and biomass a lot more, or we will start trying to get smaller, cheaper ways of buying things like gasoline, using them less. Or we will see a rise in the cost of everything associated with oil. Even these plastic drink bottles produced from petroleum products will become much more costly as the oil used to make them goes up in cost. As gas costs rise to unthinkable levels, the demand for cars that run on alternative fuels will go up. This Nissan Leaf runs on 100% electricity, and there's more and more cars like this being produced all the time. It only has a range of about 50 to 60 miles and has increased in newer models before it needs to be recharged. But that's going to be okay if oil prices go up, because cheap gas prices are one of the things that has fueled our lifestyle of living wherever we want and commuting 30 minutes to an hour to work. And it's likely that if gas prices go up dramatically, we might see whole neighborhoods become abandoned simply because they're too far away from work. Shopping areas and schools, all of these effects are what we call the indirect effect of oil. And we are seeing that now as more and more people are moving closer and closer in the city. There are some advantages and disadvantages to using oil. Some of the advantages include the fact that we have enough proven oil reserves to last for probably another century at least. It's easily transported from one area to another, and when it's burned, it gives a lot of energy for a small amount of volume. Plus, it's relatively cheap when compared to some other forms of energy. Disadvantages include the fact that we're going to run out someday, and the fact that there are large environmental costs such as pollution to consider when we use it. Burning oil releases sulfur into the atmosphere, and that's going to have an impact later on acid rain. To address the declining supply of conventional oil, focus recently has shifted into finding alternative sources for oil. One of them is the oil sand tar sand deposits, and this is the reason Canada was darkly shaded on the oil reserve map. Recent advances in technology allow us to remove the oil-containing sand layers of the ground by strip mining. The sand is heated and sort of washed to extract the oil, which is then refined to make useful petrochemicals. Then we have oil shale. It is a type of rock that contains oil, and it can be dug up and processed to release the oil in similar ways as oil sands. There are large reserves of oil sands in Canada, and oil shale is common in the U.S. The problem with both is that they require large amounts of energy inputs in order to dig them up and process them, so that lowers their overall usefulness. It's kind of like spending $15 to get $20 back. It's not as good as regular oil, where you get to spend $5 to get $20 back. Plus, oil sands and oil shales are disrupting to the land, produce large amounts of pollution, and they require massive amounts of water in order to process. However, we are increasing our technology constantly and therefore digging more and more oil shale up. So what about the next type of non-renewable energy? Natural gas. Natural gas is a mixture of gases, mostly methane, with a bit of ethane, propane, and butane in there as well. Natural gas is usually formed on top of deposits of crude oil. Because it's a gas, it's less dense, so it rises above the oil and is trapped by the layers of rock above it. When a well is drilled, the natural gas can be removed just like the oil by pumping it to the surface. Natural gas comes in several forms. And the first one is LPG. LPG stands for liquefied petroleum gas, and it's mostly propane and butane. It is chilled and pressurized to turn the gas into a liquid, and then it is stored and transported inside of pressurized canisters. Many of you have canisters like these for propane if you live beyond the city's natural gas lines, and lots more of you have much smaller canisters of propane that are used for fueling and grilling. Regular natural gas is mostly methane because the propane and butane have been removed from the LPG products. Propane is delivered by truck to individual areas, but natural gas is delivered by pipelines across the country. If you look closely at the map, there's even a pipeline that delivers natural gas to our area. The map doesn't show this level of detail, but Thomasville Utilities takes that incoming natural gas and puts it into smaller lines, one that flows to almost every house in Thomasville. Where the water lines and sewer lines run aground, there's another set of utility lines, and they are carrying natural gas for customers to use for heating and cooking. Thomasville Utilities recently started converting their garbage truck fleet to run on natural gas. The last kind of natural gas is liquefied natural gas, or LNG. This is a natural gas that has been cooled and pressurized to turn it back into a liquid so that it can be transported efficiently. It's not the best way of going about things because if it takes energy to cool it, pressurize it, and keep it liquefied the whole time, then it lowers the energy usefulness of the product. It's kind of back to the spend the $15 to get $20 back argument. So, for the advantages and disadvantages of natural gas, let's list a few. Advantages include the fact that the Earth has a lot of natural gas supply left, enough to last for another century. More importantly, the U.S. contains enough natural gas to serve our own needs without importing any, which is nice for a change. When burned, natural gas produces less air pollution than coal and oil. The only exhaust products are carbon dioxide and water vapor. Last, natural gas is relatively easy to transport inside of a country where it is produced. On the negative side, it's a non-renewable resource, but I think you already knew that. It does release some air pollution in the form of carbon dioxide, and while the overall level of pollution is better, CO2 is a greenhouse gas that is contributing to global climate change. Lastly, it is difficult to transport natural gas products over distances if there isn't a pipeline for it. So what about coal? Coal is a solid fossil fuel. The same geologic processes that create oil and natural gas also created coal, but due to a different set of circumstances, these fossil fuels ended up in a solid form. Well, it used to be used just to burn for heat. Most coal today is burned in electric power plants, and it is involved in the process of turning iron into steel. Coal is distributed all over the world, but it's concentrated mostly in the U.S., Russia, India, and China, along with a few other countries. The advantages of using coal are that it is quite cheap if you don't consider the damage it does to the environment. It's also very plentiful, especially in the U.S. The disadvantage of using coal is that it is the biggest source of air pollution in the world. When you stop to think about it, burning firewood isn't really terrible from an environmental perspective because the carbon dioxide released by the fire can be reabsorbed by growing trees and plants over the next few years, and there's no net change. But since humans have been burning coal for several hundred years, that's like releasing millions of years of stored CO2 in a short period of time. Coal also usually contains small amounts of element mercury. Now, we'll learn later that mercury is a very toxic chemical that has some serious health effects on animals, including humans. Buried underground with the coal, the mercury wasn't causing any problems. However, digging it up and burning the coal releases the mercury into the atmosphere, where it can wreak havoc in the environment. So, that brings us to the last type of non-renewable energy, nuclear energy. Nuclear energy doesn't have the same kinds of pollution issues as fossil fuels, but it goes in this group because the fuel that is used for it is non-renewable, just like all the rest. Nuclear fission reactors use specially processed uranium, which is an ore mined from the earth. It's processed to increase the uranium content in the final product, and that uranium is loaded into long, straw-like fuel rods that are lowered into a reactor. When the uranium is bombarded with neutrons, the atoms split apart and release loads of heat energy in the process. As they split, they also release more neutrons, which cause more uranium atoms to split, which keeps the process going as a chain reaction. To keep it from going out of control and overheating, control rods are lowered into the reactor, and they're made of a material that can absorb excess neutrons, so that slows the reaction down when needed. After that, it is a pretty standard process for generating electricity. Water serves as a coolant to keep the reactor from overheating, and as that water is heated by the reactor, it is used to generate steam, which turns a turbine, which spins a generator, which produces the electricity. All of the radioactive parts of the reactor are kept inside of a containment shell, which serves to limit the amount of radiation that leaves the reactor. Once the uranium in a fuel rod has been used, it is still highly radioactive and will remain so for hundreds or thousands of years. That presents a problem, because it has to be safely disposed of. The rods that this worker is manipulating are stored in a pool of water to keep them cool, and when the pool fills up, the rods are assembled together into these. Casks that contain lots of used fuel rods. The long-term goal is to transport all of these used fuel rod assemblies to an underground facility for long-term storage. But that storage facility doesn't exist yet, so nuclear reactors currently hold their waste on site. The advantages of nuclear power are that there is an abundant supply of uranium to use as fuel, and if it is used properly without any accidents, the environmental damage caused by nuclear power is very minimal. It emits very little air or water pollution. On the disadvantage side, because of all the procedures and processes required to use it safely, nuclear energy costs a lot more to produce than other forms of energy. There is always the risk of catastrophic accident, like Chernobyl, that have happened in the past. Perhaps the most significant disadvantage, though, is the lack of permanent solution of storage for radioactive waste. There is no easy answer to storing the waste. And that's it for this screencast. Thanks for watching.